Okay, hi everybody. It's time for lab number 8. This is the determination of the molar mass of a volatile liquid. The method we'll be using is known as the Dumas method or Dumas method. And we'll be using it to determine the molar mass of a volatile liquid. This could be used in a crime lab, for example, to identify an unknown gas without any fancy equipment. Let's jump right into an example, and I think it'll give you a good idea of what we're doing. Say that 0.748 grams of an unknown gas was in a 499.9 milliliter flask, and the pressure was just about an atmosphere, and the temperature was boiling water, 100 degrees Celsius. Is that enough information to find the molar mass of the gas in grams per mole? Well, let's see. You do have the grams, but we don't have the moles. But moles plays into PV nRT equals nRT, which is the ideal gas law, where P is the pressure in atmospheres, bada bing. V is the volume in liters, almost a half. N is going to be the number of moles once we solve for it. R is just a number, 0.0821. And T is the temperature Kelvin, so we have to add 273 to our Celsius. Plug all those in while rearranging the formula, and we can solve for N. And in this case, we'd get N equals, there it is, we got about 1.5 thousandths of a mole, 1.5 millimoles. And molar mass is in grams per mole, so we take those grams there, divide it by the moles, and we have the molar mass, which is about 46, which would happen to be a nice match for ethanol, suggesting that's what that unknown gas was. Okay, so here's what we'll need and how you're going to get it. You'll be needing the pressure today, and we'll put that on the board, or perhaps we'll bring in a pressure reading instrument and you can record it yourself. Make sure you get atmospheres in the end. It has to be liters, atmosphere, mole, and Kelvin. For the volume, we'll use a 250 milliliter flask, and we will fill it up and find its volume more precisely at the end. We'll just fill it up and then pour it into a graduated cylinder. R, as you know, is just a number. Temperature, we're going to use boiling water, and we'll actually measure the temperature of the boiling water. Now, we'll have to assume that the temperature inside the flask is the same as the temperature of the boiling water that was outside it, and that's a reasonable thing to assume. And for the mass of the gas that's in there, first we'll put too much liquid in there, and then we'll heat it up so that it all, once it goes down, the last drop is gone, it's all gas. We'll take it out at that point, and then that'll be all gas. Now we can just condense it and weigh it. I think what we'll do is we'll condense it and then weigh the whole thing again, and any additional mass must have come from the gas which condensed in there. So this is the Dumas method, and it's a pretty cool way to, using almost nothing at all, come up with the molar mass of an unknown gas. In essence, we place a few mils of a volatile liquid inside a flask, cover it with foil and a pinhole. The idea there is very, very important in terms of safety. If we sealed this thing up and heated it, it would pressurize and could potentially burst or even explode, sending shards of glass everywhere. So look around and make sure nobody pressurizes this system. A little aluminum foil on the top held on with a rubber band and a pinhole will keep things safe without messing up the results. So we'll boil it until it's all gas, and we should have all the data that we need. Here's the calculations that we will need today. We need 5, count them, 5 calculations. That includes the pressure in atmospheres. Make sure you get atmospheres. It'll either be written on the board or you'll measure it using an instrument. The temperature in Kelvin, not Celsius, add 273. 0.15 to your Celsius to get Kelvin. The moles of the unknown volatile liquid, that's shown up here. The molar mass, see the sample calculation to get the whole molar mass, and the average deviation from the molar mass, which we've done several times in this lab. If you still don't know what the heck that is, try looking it up to find out how you get deviation from an average. Couple questions. Why don't we need the mass of the liquid that we added? And what is in the flask once all that liquid has boiled off? Those are the 2 types of questions that you should know the answer to before you perform this lab. If it's not clear to you, talk to your lab buddies, or if you really need to in the lab, ask me. The biggest safety by far is the risk of an explosion due to somebody heating a closed system, a started-up system. We do not want that. Also, a potential danger is that once you heat something over an electrical heat source, if the vapors are volatile, are not particularly volatile, meaning that they have a density higher than air. The average mass of air is about 30 grams per mole. So if your gas has a higher density that an appreciable amount of it forms, it potentially could roll down the sides here. Even though it's a gas, it's more dense than air. And there is the risk of a fire once it goes down there. Never seen it happen. This lab, they use liquids where it's unlikely to happen, but even so, you must keep the goggles on at all times. You must stay alert, because in this lab we have both the risk of a flash flame and the risk of an explosion. So please be on your toes for this lab. Please keep the goofing around to an absolute zero. Okay, so never heat a closed system. There's an explosion hazard, there's a flame hazard, and assume that the vapors that are boiling off are harmful, and I wouldn't want to be inhaling them for too long. Move away a little bit if you're smelling a lot of these fumes. Perform it near or in a hood if you have to. And that is today's lab. Number 8, molar mass of a volatile liquid.